So this question is also related to refractive index as I mentioned in the question. The light traveling in air enter a plastic block at an angle of incidence 62. So it is moving from air to glass. So when it travels from air to glass, it will bend towards the normal. So the angle of refraction will be smaller than the angle of the incidence, and the formula when it travels from air to glass, the refractive index is sine I over sine R. So, and the refractive index is given 1.48. So refractive index is 1.48, sine angle of incidence is 62, and angle of refraction we need. So we'll solve that. Moving from air to glass, the refractive index is given by a formula that it is sine angle I over sine angle R. The refractive index is 1.48. The angle of incidence is 62, so it will be sine 62 divided by sine R. So sine 62, first we'll take the value for sine 62, so sine, and your calculator mode should be in degrees, so sine 62, that is 0.88. So 0.88 divided by sine R is equals to 1.48. Then this 1.4, we need sine R, so we cross multiply. Sine R will move to numerator and 1.48 will come down in denominator. So the sine R will be equal to 0.88 divided by 1.48. So it is 0.88 divided by 1.48. That will give 0.59. So this ratio is 0.59. So it means the value of sine R, the value for sine R is equals to 0.59. But we need R only, so it means R will be equal to sine inverse 0.59. So we have to take a sine inverse. How to take a sine inverse? On your scientific calculator, there's a button shift or invert. So we press shift first and then sine inverse, and that is the last answer is there. So sine inverse of our last answer, that will be 36.48. So the angle of refraction should be 36.48. Now we check the options. So 36.48, it matches, it's close to 37. That's why it's not 42, it's not 28, it is not 18. Is it clear, this question? Some of the questions are from different. So in this question, the diagram shows a ray of a light traveling from X at an angle P. Okay, it is about critical angle. So that's the next topic after refractive index. Now, in the question, question 26, which diagram shows how a ray of a light could pass through a glass block? So when we draw the normal, moving from air to glass, it bend towards the normal, and moving from glass to air, it should bend away from the normal. So it is A is the right answer. Why B is wrong? Because when we draw the normal, when it is moving from air to glass, it should bend towards, like the direction in which this ray should move, that is towards the normal as the speed is decreasing, but it is moving away from the normal. That's why B is not the right answer. Why C is wrong? Because in C it is passing along the normal. So when the ray of the light is passing along the normal, what should happen? It should pass straight. And why D is wrong? Because when it is bending, it's not like going in the direction of normal, it bends slightly towards the normal, but not like same as the direction of normal. That's why D is also a wrong answer. So A is the correct answer. First it bend towards the normal and then it will bend away from the normal. Why B is wrong? Because as you can see in B, when we draw the normal, the perpendicular, so this is the direction in which the ray is entering. So when it move from air to glass, look, this is the direction ray enter. So moving from air to glass, it should bend towards the normal because the speed decreases. But when B is shown here, what it shows? It shows it bend away from the normal, move away from the normal. That's why B is wrong. So whenever a ray of the light is passing, it should bend towards the normal as it travels from air to glass. The refractive index of a glass block is 1.5. Use your value for speed of a light. Calculate. So what is the formula? The formula refractive index is equals to speed in air or vacuum divided by speed in the medium or a glass. So refractive index is given 1.5. Speed in air is fixed value 3 into 10 to the power 8, or speed in a glass is unknown. So we cross multiply. So x will be equal to 3 into 10 to the power 8 divided by 1.5. When we simplify on the calculator, you will find it will come out as 2 into 10 to the power 8 meter per second. So every second it will cover 200 million meters. The refractive index is given, and as I mentioned, speed of the light we need in a block or a glass, but the speed of the light in air is fixed, which is 3 exponent 8. Figure 6.1 shows a protractor superimposed on the path of ray of the light. We don't multiply, as you can see here. If you see this x, the formula is refractive index is speed of light in air divided by speed of light in glass. Refractive index is 1.5, speed of light in air is 3 exponent 8, and speed of light in a glass is x. So this x first will be multiplied there. You can solve in steps if you find this as difficult directly moving the two numbers. So x is divided here, x will be multiplied. So it will become 1.5x is equals to 3 into 10 to the power 8. And now this 1.5 is multiplied with x. Other side it will be divided. So x will be equal to 3 into 10 to the power 8 divided by 1.5. So it will give you 2 into 10 to the power 8 meter per second. So figure 6.1 shows a protractor which is superimposed on a path of ray of a light. The light is traveling in a glass towards the boundary with air. Then use a protractor, measure the angle of incidence. So the protractor is placed. We want to measure the angle of incidence. Angle of incidence, when I draw the ray of the light, this is the incident ray. We want to measure the angle of incidence, so we always measure from the normal. So we want this angle. Look, this is 90. It's written 90 here. And this is about, because 0, 10, 20, 30. So this is 55 or 56 is there. I use the thick lines. But when you check, this is 50 and 55. So this is 55. This angle of is 55. Here it is written 0 and 0, and till this point it is 55. So the question is, what is the angle of the incidence? What is this angle? Because angle of incidence is for always from the normal. So normal and incident. What is, if this angle is 55 on the left hand side, it is 55. What will be this angle between the incident and the normal? So it will be 90 minus 55, which is equals to 35. Yeah, that's right. So angle of incidence is 35. So when you write 35, you will get 1 mark. Then the refractive index of the glass is 1.56. Calculate the angle of refraction. It is moving from glass to air. So when the ray travels from glass to air, the formula for refractive index is sine R divided by sine I. Because the ray is in air, it is glass and it is moving in air. The refractive index is 1.56. Sine R we don't know, and sine angle I, the angle of incidence, is 35. So we'll use a scientific calculator, because moving from glass to air, the refractive index is equals to sine R divided by sine I. The refractive index is 1.58. That was given in the question. So that is 1.58. Sine R we are finding, and angle of incidence we already measured. That was 35. So sine 35, that is 0.57. So this is 0.57. Sine R we don't know, and 1.58. Now this 0.57 is divided, other side it will be multiplied. So we'll multiply these two factors. So 1.58 multiplied by 0.57, that is 0.9. So when we multiply these numbers, we'll get as 0.9. So this 0.9, the 0.9 is equals to sine R. But we need R, we need angle. So this sine will move other side. Whenever sine move other side, it will become sine inverse 0.9. So sine inverse 0.9 will be equal to R. So on your calculator, you will use shift or invert sine inverse. The answer, the last answer. So it will give us 64.3. So this will be 64.2 degrees, the angle of refraction. So here, the angle of the refraction, when we substitute the values, we'll get as 64.3. Is it clear, this question? As it was traveling from glass to air, so the formula is sine R divided by sine I. Refractive index was 1.58. Sine R we don't know. Sine I was there 35. So this it will be multiplied there. So it is 1.58 multiplied by sine 35, that will give us sine r. So when we multiply these two values, it was 0.9 is equals to sine r, and we need r only, so sine will move other side. It will become sine inverse. So it will be sine inverse 0.9 is equals to r, so which is 64.23 degree. Then another question. A block is made from a particular type of a glass. The figure 6.1 shows a light passing from air to glass. We have to find the refractive index. To find the refractive index, because it's moving from air to glass, so refractive index is sine I divided by sine R. So what is the angle of incidence here? The angle of incidence is always from the normal. So what is the angle of incidence? What is this value? If the angle between the ray and the surface is 29, so what will be the angle of incidence here? If the total angle is 90, this is 29. What will be the angle of incidence? That is 61. So this angle of incidence is 61. And angle of refraction is already given 33. So we substitute the values. Refractive index is sine 61 divided by sine 33. So use the scientific calculator again. Sine 61, as it is moving from air to glass, the refractive index is equals to sine angle I over sine angle R. So sine 61 divided by sine 33. Instead of solving both of them at the same time, you can first solve numerator separately. So I put sine 61. Yeah, that's right. 1.6 will be the answer. So I get sine 61, which is 0.87 divided by sine 33. So sine 33, that is 0.54. That will be value for n. And when we simplify this 0.87 divided by 0.544, that is equivalent to 1.59 or 1.6. So the refractive index is equals to 1.6. And no unit for refractive index because it is a ratio. It does not have any unit. Then the second part, critical angle, we did not discuss yet, so we'll leave. In question 5, the speed of the light in air is 3 exponent 8 and speed of the light in a liquid is 2 exponent 8. We have to calculate the refractive index. So refractive index is equals to speed in air, speed of light in air or vacuum divided by speed in the medium. So speed of light in air, that is fixed, 3 into 10 to the power 8, and speed in the medium is given 2 into 10 to the power 8. So when we simplify, we'll get as 1.5. Then a ray of a light is incident on the surface of a liquid at an angle of 60. So it is traveling from air to glass, like there's a liquid and it is moving from air to liquid, not glass. That's why it bent towards the normal, or the angle will decrease. So the angle of the incidence is given, that is 40. We need angle of refraction. So, and the refractive index we already work out, that is 1.5. So the formula for refractive index when moving from air to glass or air to liquid The refractive index is sine I over sine R. Refractive index is 1.5. The angle of incidence is given in the question, that is 40, and angle of refraction we don't know. Then sine 40, what is the value for sine 40? So sine 40, that's equal to 0.64. So sine 40 is 0.64. This is 1.5 and this one is sine R. Then the sine R will move other side, and one sine R will move to numerator and 1.5 will come in denominator, cross multiply. So it will be sine R is equals to 0.64 divided by 1.5. So 0.64 divided by 1.5, that is equal to 0.42. So sine R is equals to 0.42. We need R only. So sine will move other side. It will become sine inverse 0.4. So we use shift or invert sine 0.4. So invert sine 0.4, that is equals to 23.5. So the angle of refraction will be 23.57 or 23.6, I can say. So when we substitute the value, the angle of refraction will be 23.6. So it's of 2 marks. Is it clear? So these are some questions related to topic the refractive index. So sometimes refractive index, an angle, one of the angle is given and you need the second one, and sometime angles are given, you have to find the refractive index.